Hi, it's Mrs. Finley here. So we're going to be talking today about relations and functions, Math 10C, blocks 2 and 4. And so we have blocks, this is Finley, Math 10C. We're in March, April 2020. And this is blocks 2 and 4. Okay, now if I go fast, that's okay. You can always stop me, slow down, rewind, and watch it again. And there might be time that I actually start you. Let's start. So we're talking about interpreting and sketching graphs. So graphs are seen everywhere in media. They appear in surveys, stock markets, weather, in our utility or phone bills. And the purpose of making graphs is to change data that we see in the form of numbers. You might see a column, a table of numbers comparing money and temperature to time. And we want to put it in a visual representation. And these representations can then be more easily understood, and we can draw conclusions or inferences. So in math, we gather a lot of information from a graph. So for example, first one, this graph shows the depth of a scuba diver as a function of time. So we have our two axes. This one here is our time, and it's important to note the units, our minutes. And here we have the depth, meaning how low in the water the diver goes down. And it's measured in meters. So looking at the graph, we want to know how many minutes did the dive last? Well, it started at 0 and ended right there, which is 30 minutes. So that's how long the dive lasted, 30 minutes, because we looked at the start and the end. At what times, and notice it says times, did the diver stop her descent? Well, if this is her depth, that means as it increases, she's going lower. So in this section and in this section, she's not going lower anymore. So those times are between 4 and 8 minutes. And from 10 to 14 minutes. Okay? And then the last question, what was the greatest depth the diver reached? Well, the greatest depth she reached is that top point there of the graph, 20 meters. And how many minutes was she at that depth? Well, she was there from 10 to 14, so 10 to 14 minutes. So she was there for 4 minutes. Okay, so all of that we just took from the graph and we interpreted it and answered some of those questions. The information is all provided there, and all we have to do is take a look of what's there. Now the second one here, we're looking at interpreting a graph that shows the costs and masses of various bags of popcorn. So what we've done on these axes is we have our mass in grams versus our cost in dollars. Again, take a look at what the axes are, because they tell us what we're graphing. And this should also be information provided on the title. So those are things, if you were to sketch a graph, you would have to include those information. So looking at this, it wants to know what bag is the most expensive and what does it cost. So we would look at the cost axis here, and we would look for the one that's the highest. So that's bag C. And according to the graph, it is $7. Okay. Which bag has the least mass? So looking at the mass, the lowest one is bag B. And its mass is, it is about 500 grams. Okay. Which bags have the same mass? So looking at the mass, we want two bags that occur at the same point. So that would be bags D and E. And that mass is, we look down below, 1,800 grams. Which bags cost the same? what is this cost? Well, then we would look at the cost, and we have these two bags happening at the same level for cost. So that's bags A and E, and they cost $4. Okay? And which of bags C or D has the better value for money? So comparing C and D, we're looking at the two of them. C is more expensive and it has less mass. So I would say that bag D is, because it has more mass, so you're getting more for less money. That's the better deal. Okay. Example number 2. It has a number of scenarios here, and it wants us to match each scenario with its appropriate graph and justify our answer. So looking at each of these, we want to know, the first one is the height of a bungee jumper after a jump. Well, thinking about a bungee jumper, when they jump, they go up and down and up and down and up and down. So I would say that this one would be our bungee jumper. And that would mean that on this we would have height. We know it's over time, but the height would start up and go down and up and down, etc. Then the next one is the vertical growth of a tree. Well, the tree starts very small and then gets bigger and bigger and bigger. So looking at our 3 remaining graphs, that's going to be graph A. And again, we're graphing height versus time. Then we have the temperature of a cup of hot chocolate as it sits on a table. Well, it would be, if we look at the two of them, it's going to start high, and then as it cools, it's going to get cooler and cooler and cooler and cooler. So it's temperature versus time. So I think it's going to have to be graph B. So this is the hot chocolate. The temperature starts high. As time proceeds, it gets cooler and cooler and cooler. And then the last one, Calgary's daily mean temperature. Well, in the morning, if this is temperature, starts off cool. As the sun comes out, it gets warmer and warmer and warmer. Then as we get back towards the night, it gets cool again. So this is going to be Calgary's mean temperature. Okay. With graphs, it's thinking about what's going on and thinking about what is happening. Sometimes you have to fill in the data. Sometimes you have to just use more just, I would say common sense, but also thinking about what exactly is going on in that graph, okay? Now, because my graphs take a little time to, or they have to be a certain length in order to upload them to YouTube, I'm going to stop here, take a little break, and do a separate video for the rest of the notes so that I can upload them to YouTube. So